All right, again, so this is 5.6. And again, a direct variation is a linear function. And it fits this form right here. This form. So it looks like y equals kx. So where that number that's multiplied, or the number that x is multiplied by, the k, that's called the constant of variation. And so that's what you're looking for in these equations. It's just y equals some number times x. All right? K is the coefficient of x. And as long as it fits that form, it's called a direct variation. Again, it's just a linear function. If you graph it, it's a straight line that will pass through the point 0, 0. So these are pretty quick here in the beginning, like that first one. All you got to do is look at this and decide, does this right here, y equals 3x, does that fit this form right here? Yeah. And k would equal what? 3. What's that? 3. Yeah, the number out in front of x, the coefficient of x is just 3. So in this one right here, the answer is yes, it's a direct variation. And again, k, the constant of variation, would just be 3. But all you got to write on this is just yes. It's just yes or no. So you're just going to write yes. What about number 2? No. Well, to really decide, you have to solve it for y first. So how would you solve that second one for y? How would you get rid of this 3x right here?
Divide by 3?
We need to move it to the other side.
How do we do that?
Dewan, what's that? Shh, hold on, I got too many people answering at once. Dewan, what'd you say? Minus what? Yeah. Yeah, just subtract 3x on both sides. So subtract 3x on the left and 3x on the right. These will cancel out on the left-hand side, and you get y equals negative 3x. And then that's a positive 8, so we'll write plus 8. Does it fit that form? No. What's it got that, I mean, yeah, it's got that plus 8 there, right? That's still a linear function, okay? It's just not one that would pass through 0, 0, so it's not a direct variation. And you guys can see that, right? Like if I covered this up right here, if you cover that up, then that would work, right? If you just had y equals negative 3x, that would be a direct variation. No, but this one's not. So you write no. And then I think there's a number 3 over here also, right? So what about number 3? What do you think? Let me put the form back on there so you can see that.
Can y have a coefficient or no?
It can, because you can divide through by it to get. You still want to get y by itself, so you want it to fit this form right here. Can you make number 3? Can you make that one look like this thing?
Yeah.
Yeah.
Y equals 4 thirds x.
Yeah. Yep. How'd you do that?
We add 4x.
Yep. Let me do that first.
And then divide by 3.
Yep. So let me add the 4x first. So we're going to solve for y. That's what we're doing. So we're just solving for y. Those will cancel out on the left-hand side. So now you got 3y equals, well, 0 plus 4x is 4x. And then how would you finish solving for y? Yep, divide both sides by 3. And then these 3's would cancel out, and you get y equals 4 thirds times x. So when that x is kind of floating in the middle of this fraction bar right here, that really means that x is in the numerator, okay? Now, does that fit the form then? Yeah, this is y equals kx. This is y equals kx. K would be what? Say that again? Yeah, k would be 4 thirds. So the constant of variation would be 4 thirds. So this one's a yes. So you just write yes. Okay, then the next thing says, what would happen to this form it says, what would you get if you solve for k? That's what it says right here. So we're going to take this y equals kx, this thing right here, and we're going to solve it for k. So we had y equals k times x. How would you solve that for k?
Divide by x.
Yeah. So divide both sides by x. And then these x's would cancel out on that side. So you would get k equals y over x. Well, that's what we got to write in on this blank down here. So we get k equals y over x. All right, well, that means if you had some points or some ordered pairs that were on the graph of your direct variation, if you divide the y coordinate by the x coordinate, you should always get that same number k. So let me say that again. So if you had some points or some ordered pairs that are on your direct variation, if you take the y coordinate divided by the x coordinate, you should always get the same number k, which would be the constant of variation. So that's how you're going to look at a table of ordered pairs. So same thing. This is the homework on here is pretty quick because again on this all you got to do is write yes or no. Well, we know that again we just said that k would equal y over x, right? So we just want to do y over x for each of these points. So like this is a point on the graph right here, right? That's the point 2, 6. So you just want to do the y divided by the x. So you just do the 6 divided by the 2. You do that same thing for the next point, 12 divided by 4. And you do that for the next point, 18 divided by 6. Do all of those equal the same number?
Yeah, they all equal 3.
Yeah. Yeah, 6 divided by 2 is 3, 12 divided by 4 is 3, 18 divided by 6 is 3. So they're all equal to 3. Well, that's your k then. That's your constant of variation. And since they're all the same, they're all equal to 3, then the answer is yes, it's a direct variation. So you write yes again. So let's see, you guys can see this is going pretty quick today. So let's do number 5, same thing. So again, if this is a direct variation for each point on the graph, y divided by x should be the same number k. So in this one, we would have negative 2 divided by 1. That would be that's for this point. Here, let's do this in, let's do it like this. We'll do that in red. So that's the y divided by the x. And then for the next point, you'd have 0 divided by 3. And then for the next point, you would have 4 divided by 7. Well, are those fractions equal?
No.
No, not even close, right? These two fractions are definitely not equal. The one on the left is negative 2. The one on the right is 0. Well, these aren't equal either. 4/7 does not equal 0. So none of them are equal. So then no, it's not a direct variation. So this one you write no. There we go. We're 2/3 of the way through the lesson already. All right, and then this next blank says in words. So in other words, if you're reading a problem and you want to know if it's a direct variation, what it should say is it should say y varies directly with x.
Oh.
Yeah, you should probably turn your phone off when you put it up there. Who has that ringer?
Not me, but.
Well, it's not yours if you don't have that ringtone.
No, can you check pocket number 1?
It's someone on the bottom row.
Oh, okay.
Yeah, we're good.
Was it you, Logan?
All right, so All right, guys, focus. Let's get through this. So you're looking for those words right there. You're looking for the words y varies directly with x. If you see those words in the problem, then you know that it fits this form right here, y equals kx. All right? All right, so let's look at number 6. So, do you see those words? Yeah, it says it right here, right? It says y varies directly with x. So as soon as you see that, you know it fits the form y equals kx. So then what we're going to do, let me write that, is the first thing we're going to do is we're going to want to solve for k. We're going to want to find k. So then they give us when y equals 3, x equals 9. Well, that's really like a point on your graph. So this thing right here, what they're giving you, is that really says, that's really the point, x equals 9, y equals 3. And then we're just going to take those and plug those in there and solve for k. So we're going to take the 9 right here, and we're going to plug it in for the x right there. And then we're going to take the y value of 3, and we're going to plug that in over here, like that. So then if we do that, then this thing should say 3 equals k times 9. So then how would you solve that for k? Yeah, just divide both sides by 9. So divide the right side by 9, divide the left side by 9. Those will cancel out. And I will get k equals 3 over 9, which reduces to 1/3. Well, now that I know what k is, I can write my direct variation. So let's come over here. I'm running out of room. So now I know that my direct variation looks like y equals k, which is 1/3 times x. Well, then to answer the question, after I find my direct variation, they want me to find another point on the graph, if you want to think of it that way. I know the one point was the point 9, 3. I'm looking for another point right here where the x value is 21. So really what I'm doing then is right here. I'm looking for some point here where the x value is 21 and the y value we don't know. Okay? So all I got to do is plug in 21 for the x. So now that I have my direct variation, I'm just going to plug the 21 in right there for x. And that'll give me y equals 1/3 of 21. Yep. 1/3 times 21 is the same thing as 21 divided by 3. So the answer is 7. So we get y equals 7. All right, let's try one more like that, and that's it. So we're going to do the exact same steps, okay? Well, first of all, does it have those words in there? Does it say y varies directly with x? Yeah. So as soon as you see that, you know that this will fit the form y equals k times x. All right, then we're just going to take the x value. Take the x value and plug it in right there. And take the y value and plug it in right there. And so then this thing will look like 4.5 equals k times 0.5. And then how would you solve for k? Good. Yep, divide both sides by 0.5. Those will cancel out on the right-hand side, and then we get 4.5 divided by half. What's that? Yes, it is. So we get k equals 9. So now we can write our direct variation. It's going to be y equals k times x, where we know that now that our constant of variation k is 9. So it's going to be y equals kx, so it's going to be y equals 9x. All right, and then we're just going to have to solve for this other point on the graph. It tells us the x value is 10, right? So all we got to do is take that 10 and we're just going to plug it in right there for the x. So we get y equals 9 times 10, which is, so we get y equals 90. So really, again, it's like they gave us a point on the graph. They gave us the point 0.5 comma 4.5. We know that's on the graph of our direct variation, and we're just finding the y coordinate of another point on that graph. That's all we're doing.